IGBT insulated gate bipolar transistor is a complex semiconductor composed of bipolar triode transistor and a single-pole MOS transistor device. It is used in high-power devices for power conversion and control. It can be directly applied to the main circuit of power. It is an electronic device that can realize power change. It is widely used in rectifiers, inverters, choppers, AC voltage regulators, and other circuits. In this class, we will learn about the structure, principle, and application of IGBT. To understand IGBT, we need to know the classification of semiconductor devices. Power semiconductor devices are according to controllability. It can be divided into unidirectional, semi-controlled, and fully controlled. According to the driving method, it can be divided into current drive and voltage drive. Uncontrollable types can be controlled by control signals, such as ordinary power diodes. Semi-controlled types can control conduction, but not the turn-off, such as the thyristor. Fully controlled types can control their conduction and cut-off, such as power transistors, GTR, MOSFET, and IGBT. Three-dimensional field effect transistor devices are controlled by current signals to turn on or off, such as transistors. BJT, voltage-driven semiconductor devices, are controlled by voltage signals, such as MOSFET. IGBT. In recent years, IGBT has a new power switch device have gradually been recognized by people. IGBT is composed of BJT and MOS. It is a fully controlled, voltage-driven power semiconductor devices. It belongs to insulated gate bipolar transistor. IGBT is called the CPU of the power electronics industry. It can adjust the voltage, current, frequency, phase, etc. in the circuit according to the signal instruction. It is widely used in home appliances, new energy vehicles, new energy power generation, smart grid, rail transportation, aerospace, and other fields. Next, we will learn about the internal structure and principle of IGBT. The internal structure of IGBT. This is the symbol diagram of IGBT. It is developed on the basis of power insulated gate field effect transistor. It's a composite switching device composed of the insulated gate field effect transistor and the power transistor technology. In the figure is the internal structure of the insulated gate field effect transistor. The right figure shows the internal structure of IGBT. It is triode transistor and MOS composed of a complex semiconductor device. Therefore, it also has the advantages of both devices. IGBT is formed by adding a P- layer to the drain of the power insulated gate field effect transistor MOSFET. The N- region is called the source region. The electrode on it is called the emitter source, namely the emitter E. The control region of the device is the gate region in the control region. The electrode above it is called the gate, G for short. The electrode attached to the drain region is called the drain. The emitter electrode, namely the collector C in the circuit using IGBT. We can control it like a transistor or a MOSFET. We can control the gate and emitter of IGBT and voltage magnitude to control the turn-off and blocking of IGBT. Second, the working principle of IGBT is shown in the figure. What is shown in the figure is the equivalent circuit of IGBT. Let's learn about the working principle of IGBT together. The turn-on and turn-off of IGBT is determined by the voltage, G between the gear gate and the emitter. When the voltage between the three poles and greater than the emitter is positive and the turn-on voltage huge, a conductive channel is formed in the MOSFET and provides base current for the end transistor, which turns on the IGBT. When there is no signal and reverse voltage between the emitter and collector, a conductive channel formed in the MOS transistor will disappear. The transistor space current is cut off. IGBT is turned off, it is a fully controlled device. IGBT is crucial for new energy vehicles, also plays a vital role. It is mainly used in electronic control, vehicle air conditioning. Inverter. It is the core technology component of electric vehicles and charging piles and other equipment. In new energy vehicles, the main function of the motor drive system is to exchange energy, which is the conversion from DC to AC, or from AC to DC. The conversion from DC to AC is called inversion. The main power device used is IGBT. As a power conversion device, IGBT is actually more commonly used for high voltage power conversion. During the conversion process of electric vehicles, the battery voltage is generally above 200 watts over 300 amps of overcurrent capacity. The breakdown voltage of power devices is about 612 watts with a switching frequency within 20 kHz. IGBT modules can be used to achieve high voltage and high current operations. In this class, we have learned about the internal structure and applications. We know that IGBT, which is a power conversion device, is widely used in many electronic devices. Among them, IGBT in new energy vehicles is the key device to determine the energy efficiency. Nowadays, the development of new energy vehicles has entered a fast lane. When researching and developing new energy vehicles, in addition to a solid theoretical foundation, we also need to cultivate correct label values. Only by doing so can you become a true professional in new energy vehicles. Please think about it after class. What are the outstanding advantages of IGBT? Both IGBT and MOS2 have some electrodes, which can also be used as a switch. How to choose between the two?